Hello guys, I'm GT. Let's continue with differentiation part 2, limits today. So as you can see here, this is a summary of a limits with first table method, second substitution, third factorization, fourth first principle method. And today I'm going to introduce an extra one, which is L'Hopital rule, and you might learn it in a pre-U if you're gonna start further your study in the future. So this can help you to check if your first three method the answer is correct. Okay? So what is limit? In the limit, you will see that there's a function of x, fx, and then x is approaching to something. This something can be 1, 2, 3, 4, 5, 6 to infinity, or it can be 0, or it can be negative. Okay? Whatever. Okay? So in this first part is about table method, and mainly it's when x approaching 0 and infinity. So first, you got a limit of x approaching 0 of a function of 1 over x. So since it's approaching 0, right? So we're gonna test it one by one, the value of x, and we will see the value of 1 over x, okay, to observe in order to find what is a 1 over x when x is 0. So we first start with x is 1, and then we found out that 1 over x is 1, x equal to 0.1, 1 over x is 10, and then we slowly move down the value so that we observe the value of 1 over x. And we found out that when x is approaching 0, right, 1 over x is getting bigger and bigger and is approaching infinity. So we can conclude that limit of 1 over x when x approaching 0 is infinity. And in math, infinity is undefined. Okay. So second example is a reverse of a first example where x is approaching infinity and you want to find 1 over x when x is infinity. So we first start with x value as 1, and we slowly increase the value of x until it approaches infinity. And then we observe a value of 1 over x, and we found out that 1 over x keep on decrease, and it approaches 0 when x approaching infinity. So we can conclude that limit of 1 over x when x approaching infinity is 0. Okay, let's move on to the second part, which is substitution. So I would like to lead by example. This is the first question. Let's solve it by using substitution method. So first, we copy down the question. So next, what is substitution method? Substitution method, you just sub it in. So sub in a equals 2 at a. Okay, so this is this. Easy, right? Let's take the second example. You got limit of b approaching negative 3, b plus 4 over b minus 1. Okay, so just sub in. You got 1 over 4 negative 4. Okay, so this is the third part, factorization. Let's see the first example. Okay, so since this is x plus 5, I would like to have another example when this is x minus 5. So let's see what it goes. Okay, so let's do the first example when it is plus. Okay, so as we said, this is factorization. So can you see that what can be factorized? Obviously it's a denominator. Okay, so let's factorize it. A square minus b square equals to a plus b, a minus b. So what can be factorized? This. So you got when 1 over 0, this is undefined. Okay, Okay, so let's see the second example. What if it is x minus 5 over x squared minus 25. So you can see that if you factorize out the thing like what we did just now, you will see that you cross out this thing, and then this is 1 over x plus 5. So if you put in the limit, what you got, this is 1 over 5 plus 5, which is 1 over 10. Okay, so let's do the second example, or we can say that it's third one. Okay, so as usual, copy down the question, and then we see what can be factorized. So in this case, obviously it's a numerator. Okay, so if you want to factorize, you got two brackets, and then you see it's negative 3. So one is plus, one is minus. Which one is larger? Negative 2, so negative 1 is larger. So negative 3 plus 1. Okay, like usual, cancel out. So you got this. Substitution, sub it in. We are done. Okay, easy, right? So here comes the fourth one, which is a special case if you got 0 and infinity. So here we got two methods to solve it. So the first method is here. I'm gonna explain it. First, you try to factorize it. If it cannot be factorized or it can be factorized, you continue with second step, which is times 1 over x power n, and this n is the highest degree of a polynomial. You times this thing to both denominator and numerator part. So how to see this n? Here is an example. In this case, if you can see the numerator and denominator, what is the highest power of x? It's 2, right? So in this case, n is 2. If the highest of power of it is 3, then you divide by x cubed. Okay? If the highest power is 4, you divide it by x to power 4. Okay? So after you divide it, you sub whether it's 0 or infinity into it, like the substitution method. Okay? And then you determine the value of a limit by using this concept. Anything divided by infinity is 0. Anything divided by 0 is infinity. Okay, so this is the first method. We're gonna do it here now. So using a first method, first you see if it can be factorized or not. If it cannot, then we continue to the second step. Okay, so from what I see, this cannot be factorized. So what we do, we divide it by x to the power n, or you can say that you times with x, 1 over x power n. Okay, in this case, n is 2. N is 2. Okay, so what you got? X squared divided by x squared, you got this. Then this one, you got this. This. Okay. This. Okay, so if you sub infinity inside, what you got this. So what is anything divided by infinity? It is 0. So you cancel out everything, you got this. So what if we use the second method? The second method here I'm gonna introduce is L'Hopital rule. It's a rule that you're gonna learn in pre-U if you further your study, but don't worry, it's easy and simple. Okay, you can use this to check anything, any answer related to limits. This includes the previous 3 parts that I taught in this video. Okay, so the L'Hopital rule say that if you got the limit x approaching k, the k can be whatever, and then this a over b. And a and b is a function in terms of x. So this limit is the same as the limit of the derivative of a over the derivative of b. And L'Hopital rule can be applied n times, okay? No matter how many times, as long as you get the answer, okay? So it might be hard to understand this, but let's go through an example, okay? So we use the same example. You got this. So L'Hopital rule says that this limit is the same as this limit. If I differentiate dy dx over dy dx, okay? So what is the dy dx of the upper part? If you differentiate it, it is this. What is the dy dx of the lower part? If you differentiate it, it is this. But then if you sub it here, if you sub infinity here, you still got infinity over infinity, which is infinity. So this cannot solve this limit, right? So you're gonna apply L'Hopital rule again. So you're gonna differentiate the denominator and numerator again. So if you differentiate it again, you got this. So this is definitely x approaching infinity 2, which is 2. And then you can see that these two are the same answer. So this can be applying to previous 3 questions as well. If you guys would like to try, this is a method to check if your answer is correct. Okay? So let's move on to the last part of this video, first principle method. So first principle method, normally you will be given a y in terms of x, and then the first step is to replace y with y plus delta y, x with x plus delta x. Then you move everything from the left to the right, and then left delta y at the left hand side. Then you divide this whole thing with delta x, so you got delta y over delta x equals to this whole thing. Okay, so next you apply this equation, so you got dy dx. Okay, note that what is delta? Delta is change. So when I say delta y, it is the change of y. When I say delta x, it is a change of x. Okay, so let's see the first example. So what is first step? You replace y with y plus delta y, x with x plus delta x. So move everything to the right hand side, expand it, you got this. Oh, this is negative, sorry, a mistake here. Okay, if you move the plus to the right hand side, it is negative. Okay, so what is y? Y is negative 3x squared. So expand this, cancel out, you're left with this. Okay, now you divide both sides with delta x. So you got this. And the last part, you apply the dy dx equals to limit of x approaching delta x approaching 0 to, what is your delta y over delta x? It is this. Okay, so this is equals to 6x plus 3 times 0, which is 6x. So can I say that dy over dx equals to 6x, and we are done. So thank you for watching. If you all would like to see more engineering and mathematics video in the future, hit the subscribe button. See you guys next time.